5.3 Catalysts. Catalysts are substances that affect the rate of chemical reactions without being chemically changed themselves at the end of that reaction. Catalysts are usually used to speed up reactions, so they are rather important in industry. It is cheaper to speed up a reaction by using a catalyst than by using high temperature and pressure. This is true even if the catalyst is expensive, because it is not used up. Catalysts work because they provide a different pathway for the reaction, one with a lower activation energy. Therefore, they reduce the activation energy of the reaction, the minimum amount of energy that is needed to start the reaction. For example, for the decomposition of hydrogen iodide, 2Hi equals H2 plus I2. If we were to do this without a catalyst, the EA would equal to 183 kilojoules per mole. If we were to do this with a gold catalyst, it would take us 105 kilojoules per mole. If we were to do this with a platinum catalyst, it would take us 58 kilojoules per mole. You can see what happens when you lower the activation energy if you look at the Maxwell-Boltzmann distribution curve in figure 2. The area that is shaded pink represents the number of effective collisions that can happen without a catalyst. The area shaded blue plus the area that is shaded pink represents the number of effective collisions that can take place with a catalyst. Catalysts do not affect the enthalpy change of the reactions, nor do they affect the position of equilibrium in a reversible reaction. See topic 6.1. A few examples of catalysts: iron, platinum and rhodium, nickel, aluminium oxide and silicon dioxide. Platinum and rhodium, H+ absorbed on solid silica phosphoric acid, and H+. These are used for making fertilizers, explosive, margarine, petrol, removing polluting gases, making ethanol, and making certain solvents. Different catalysts work in different ways, but most were discovered by trial and error. All new petrol engine cars are now equipped with catalytic converters in their exhaust systems. This reduces the levels of a number of polluting gases. The catalytic converter is a honeycomb made of a ceramic material coated with platinum and rhodium metals, the catalysts. The honeycomb shape provides an enormous surface area on which the reactions take place, so a little of these expensive metals go a long way. As they pass over the catalyst, the polluting gases react with each other to form less harmful products by the following reactions. Carbon monoxide plus nitrogen oxide equals nitrogen plus carbon dioxide. And hydrocarbons plus nitrogen oxide equals nitrogen, carbon dioxide, and water. The reactions take place on the surface of the catalyst in two steps. First of all, the gases form weak bonds with the metal atoms of the catalyst. This process is called adsorption. This holds the gases in just the right position for them to react together. The gases then react on the surface. And secondly, the products then break away from the metal atoms. This process is called desorption. This frees up room on the catalyst's surface for more gases to take their place and react. The strength of the weak bonds holding the gases onto the metal surface is critical. They must be strong enough to hold the gases for long enough to react, but weak enough to release the products easily.